Hello, today we are going to learn about resistor combination. What does combination mean first? Combination means the way resistors are connected together in a circuit. This means resistors can be connected side by side or end to end or in other different ways. So today we are going to learn the different ways resistors can be combined in a circuit. Resistor can be combined in series, parallel, series, parallel or mixed combination, delta or triangle connection, Y or star connection, T network, pi network, and resistor can also be combined in bridge or western bridge combination. And these are the main types of resistor combinations. Let's start with series combination. If we connect this resistor with another resistor, and as you can see their connection is end to end, this type of connection is called a series connection. This means the two terminals of both resistors are connected together and current can only flow in single pass from resistor 1 to resistor 2, and there is no alternative path as you can see. So when we define a series combination of resistors, a series combination of resistors is when two or more resistors are connected end to end in a single path. In these different combinations, we observe that they have their own properties. In each combination we listed above, voltage, current, and resistance have their own quantities and behaviors. So, to see the behavior or properties of voltage, current, and resistance, we measure the we measure them using a multimeter, but we have to give power to see resistors and these three quantities. Let let us connect a 9-volt battery. When we measure the battery terminal wires, we get 9 volts. And now let us measure resistor 1. When we measure resistor 1, we get 4.5 volts, and when we measure resistor 2, we also get 4.5 volts again. This shows that the 9 volts from the battery comes and split across both resistors. That means if we add 4.5 volts plus 4.5 volts, we get 9 volts, which is equal to the battery voltage. So in each or in each resistor or in a series combination of resistors, as we can see, the total voltage is the sum of the voltage across each resistor. In this example, we get 4.5 volts across resistor 1 and 4.5 volts across resistor 2. Now let us see the behavior of current. Before we see the behavior of current, we need to know the resistance of each resistor, because current is not fixed like voltage. It is not fixed by the battery, which means it depends on the load, which is our load is resistance, a resistor. And let us say resistor 1 and the resistor 2 have equal resistance, which is 50 ohms for resistor 1 and 50 ohms for resistor 2. When we measure the current across resistor 1, we get 90 milliamperes, and when we measure current across resistor 2, we again get 90 milliamperes. And this shows or indicates that in a series combination, the current through all resistors is same. As you can see, both resistors have the same current, so we can say current the current is the same through all resistors. In a series combination of resistors. For resistor 1 we get 90 milliamperes, and for resistor 2 we also get 90 milliamperes. Now let us see the resistance of both resistors, or the total resistance, which is also called equivalent resistance. To measure the resistance of both resistors, we put our multimeter probes on the ends of both resistor terminals. When we measure, we get 100 ohms. This means to get the total resistance of resistors in a series, we simply add them. So in series, the total or equivalent resistance is the sum of the individual resistances, which is 50 ohms plus 50 ohms gives us total resistance of 100 ohms. Now let us write these explanations in mathematical expressions. So the total voltage is the sum of voltage across each resistor, and this means V total is equal to V1 plus V2 plus V3 plus so on. And the current is the same through all resistors. This means I total, or I, is equal to I1 is equal to I2 is equal to I3 is equal to so on. And the total or equivalent resistance is, as we know, is the sum of the individual resistances. This means mathematically R total is equal to R1 plus R2 plus R3 plus so on. Equivalent resistor. When we say equivalent resistor, what do we mean? First, let us look at this circuit. We have In this circuit we have two resistors here. These two resistors can be replaced by single resistor, and this single resistor is called equivalent resistor. So these two resistors together are equal to this one resistor. In simple words, an equivalent resistor is a single resistor used to replace two or more resistors in a circuit. This equivalent resistor has a resistance, and this resistance is an equivalent resistance. And an equivalent resistance is also called total resistance or resultant resistance, or we can call effective resistance. So in electronics, if a resistor is burned or fails, we can replace two resistors in series with a single resistor, or instead of using one single resistor, we can replace it with two resistors connected in a series. As we see from the definition of a series combination, in a series combination, resistors are connected end to end. In this circuit, the resistors are connected in a straight line, one after another. So these resistors are connected in a series combination because they are connected end to end. And in this circuit also, the resistors are connected in a series. Here resistor 1 is connected to resistor 2, and the resistor 2 is placed perpendicular to resistor 1, and the resistor 3 is connected after that. And in this case also, the combination is what? Combination is a series combination because these resistors are connected in end to end. Also, as you can see in this circuit, the resistor 1, resistor 2, and resistor 3 form what? Form zigzag shape. But the main thing is to notice is that these resistors are still connected in what? In a series combination. Why do we say this is a series combination or connection? Is because in this circuit there is what? There is only one pass from resistor 1 to the last resistor for the current to flow. If there is only one pass, then all the current passes through all resistors one by one, right? This is what makes these circuits a series circuit. You can easily identify a series circuit by checking whether there is just one path for the current to flow. Okay, so first of all, we know that in a series circuit, the total resistance is equal to the sum of all individual resistances, right? And that means the total or total resistance or R equivalent is equal to what? Is equal to R1 plus R2 plus R3 plus so on. Now you might ask how do we derive this total resistance, right? So let us see this step by step. First, let us look at the circuit. We have resistor connected to a voltage source. Then the current flows from the voltage source or from the battery and then passes through the resistor. Now using this circuit we can apply Ohm's law. Using Ohm's law we can find the total resistance or equivalent resistance. We know from Ohm's law that the total voltage from the battery is equal to equivalent resistance multiplied by current. Now let us take an example with two resistors, and we know that the equivalent circuit shown above can replace circuit shown below. So from the above circuit we have what? We have V total is equal to, or V total voltage is equal to equivalent resistance multiplied by current, and the same total voltage or V total is equal to R1 multiplied by current or I plus R2 multiplied by current or I. Now as we are ready now, in a series circuit the current is same through both resistors. So we have what? We have a common current. So what we do is we take the current outside the bracket, then we get current multiplied by the sum of R1 and R2, and V total is equal to what? I times R1 plus R2. So simply V total is equal to I times R1 plus R2. Now we need to separate the current from the resistance terms. So we divide both sides by current. I times R1 plus R2 over I, and V total over I. On the right side, the I is numerator is I in the numerator is cancelled out by what? By the I in denominator. Now we are left with what? With R1 plus R2. So V total is equal to R1 plus R2, and we know that total voltage divided by current is equal to the equivalent resistance. So from the equation above, when we derive V total over I is equal to R equivalent, and that is equal to what? Equal to R1 plus R2. And this is how we derive the equivalent resistance in a series circuit. From this, we can say that the total resistance or equivalent resistance for a series combination is the sum of all resistors. So, in general, the equivalent resistance is equal to R1 plus R2 plus R3 and so on. So, in simple words, in a series circuit, we add all the resistances to get the total resistance, right? And in summation form, we can say that what? The equivalent resistance is the sum of all individual resistances starting from the first resistor up to the last resistor in the circuit.